In this lecture, I shall discuss about the three-phase to three-phase cycloconverters. To understand the conversion from three-phase to three-phase, let us first recall how we converted three-phase into a single phase. So I'm going back to my previous lecture. In previous lecture, we learned this circuit. In this circuit, we have connected two half wave converters. One is this, another is this. So by connecting these two in this fashion, we could convert a three-phase supply into a single phase. And during this conversion, we learned that to get the positive half, we operate the positive group. That means we operate the P group. And to get the negative half, we operate the negative group. And to get this positive half, the alpha is varied from 90° to 0°, then to 90°. And for getting this negative half, the alpha was varied from 90 to 180 to 90. So this was the firing sequence that we adopted to get the conversion from three phase to single phase. Now, if this one circuit is giving you a conversion from three phase to single phase, then by using the similar circuit, how we could get a three phase to three phase cycloconverter, this we will study in this lecture. In this lecture, I will not be discussing about the firing sequences or about the waveforms. Rather, I'll be keeping myself limited to the configuration used for three phase to three phase conversion. Well, to get this conversion, what we do is we connect three sets of three phase half wave circuits. Now, how do we do it? This is the first set. Why I'm calling it a set? Because this is one half wave and this is another half. This is one three phase half wave rectifier and this is another three phase half wave converter. So by connecting these two, we make one set. So this is one set, and this particular set is giving you a conversion from three phase to one phase. Now, if we wish to have one more phase, then what we can do is we can connect one more set like this. So by doing this, we will get one phase here, another phase here, and if we connect one more set, we will get the third phase. So if we connect a three phase supply here, then by operating the first set, we will get the first phase. By operating the second set, we will get the second phase. And by operating the third set, we will get the third phase. So we shall be receiving three phases at the output side. Now the condition is these three phases must be displaced by 120°. So the firing sequence can be accordingly set. The firing sequence is adopted such that if this phase is received at 0°, this is received at 120°, this is received at 140°. So 120° phase difference is mandatory to get a three phase supply at the output, and then these three phases can be connected to the three phase load as shown here. So by using this configuration, we can convert a three phase supply into three phase supply, and by varying the firing angle of these sets, by varying the firing angle of the devices used in these sets, we can vary the frequency at the output side. What is important? That the three phase must be displaced by 120°. Now, this configuration that I have discussed here, it is the most common configuration. That is why I have discussed this, and this is the most common and simple configuration that is used for your understanding. Now again, I am just going into the details of the devices contained in these boxes. So if I further draw this configuration, it comes out to be like this. So by converting this 1, 2, 3 and then connecting the load, this gives you a 3 pulse 3 phase to 3 phase cycloconverter. We call it a 3 pulse converter because 3 pulse, because here we have used 3 sets of half rectifiers, 3 phase half wave rectifiers. That is why it is called 3 pulse 3 phase to 3 phase cycloconverters. We can have one more configuration which is called a 6 pulse configuration, but in that configuration the number of devices used are double of that of this. Here in this configuration we have used total 18 thyristors. In another configuration we will use 36 thyristors, the double of 18. Now this configuration gives you a double voltage compared to the previous configuration. So this configuration is called a 6 pulse 3 phase to 3 phase cycloconverters. It employs 36 thyristors. Now you can see this is one set of dual converter, this is another set of dual converter, and this is the third dual converter. So basically by connecting 3 dual converters we can get this configuration. The point important to note here is the load, the 3 phase load, the phases of these 3 are isolated. So basically these 3 are isolated because you are feeding the 3 dual converters from the same supply. If you connect these 3 phases at the load side, then what will happen, the positive group of one output phase and the negative group of the other output phase, they will be connected together, and if they are connected together there will be a short circuit among the two converters, and this short circuit is not desirable. To avoid this, we isolate the three phases of the load. Now, if you wish to connect the load in either star or delta, then what you can do is you can also isolate the supply side. The supply could be given to these 3 dual converters through this transformer, in which there are 3 secondaries. The first secondary will provide the supply to first converter, secondary 2 will give the supply to second converter, secondary 3 will give the supply to the third converter. In this configuration, the supply side is isolated, however the load is connected. So this is the another configuration that could be used, and this configuration, it allows you to connect the load in either star or in delta, but we need a separate transformer for this purpose. Here the devices are used, the devices which are used are double of that of the first configuration, three pulse configuration. But the benefit, because here we have used the double of the devices, there is a benefit also. The benefit is the output voltage and the VA rating of this circuit is double compared to the 18 thyristor configuration. In addition, this circuit gives you a smoother variation of the output voltage, but because the number of devices are increased, the complexity of this circuit is more, and this circuit is obviously more expensive compared to the 18 thyristor configuration. Well, I think in this lecture for 3 phase to 3 phase conversion, I think this is enough. The students need to know these two configurations, one with the 18 thyristors, another with the 36 thyristors. I think this is enough for 3 phase to 3 phase cycloconverters. The reference book that I have used for complete cycloconverters is one by Power Electronics by P.S. Bhimra, and another book that I've used is Power Electronics by M.H. Rashid. Both of these books describes the working of cycloconverter in a very good way. Thank you.